Hi everyone, and thanks for joining me today. Also, big shout out to the organizers for this awesome opportunity for me to talk at the legendary KotlinConf. Welcome to diving into advanced Compose Multiplatform Modifiers and their impact on multi-platform development. I know it's a long title, but we are all embracing multi-platform development these days, so yeah, let's have a look. My name is Meike Felicia Hammer, and I'm working for adesso Mobile Solutions, which is like a large German company doing like plenty different flavors of enterprise projects where we are having fun using different technologies for different branches, and we are like more and more embracing Kotlin multiplatform for our multi-platform development these days. What we are going to look to today is like first some interesting modifier stuff coming from the Android perspective. Then we'll have a look how we can integrate that into like Compose Multiplatform and what modifiers are in that ecosystem. And after that, we see how we can write our own custom modifiers, do some little modification madness, and finally see how the impact on multi-platform development is going with these modifier stuff. So let's jump right into it. Like a little fun side project of me is like, I realized these cuttlefish creatures coming from deep sea are actually the best modification masters I know on the planet, because they are doing quite similar stuff that we want to achieve with our modifiers. For example, they are capable of like changing their skin color by using chromatophore skin cells, so they can expand them and shrink them, and by doing that, different colors can appear. Also, they have the capability to change their body shape by using some muscles called chambers. For me, it's not that good possible as the cuttlefish can do it, but yeah, they easily can change their body shape. Also, they have some muscles called papillae for skin texture. So if they want to appear just like in a different shape, they easily can do that by modifying their muscles. And last but not least, they are also capable of doing some behavioral patterns. So if they want to hide for some other hunters to not become a prey themselves, they could just imitate being a rock and hide themselves by doing so. Or they could, like, I don't know, try to imitate a crab and walk that way around the floor and just do their camouflage thing. And funnily, they are also capable of doing like a flashing strike through their body, where they can then hypnotize their bait and maybe eat it at the end. So they are like pretty awesome, but I'm not sure if we can hypnotize people with modifiers. But let's see what a modifier is. In general, we also can change size, layout, behavior, and appearance of our composables. So it's there to decorate and augment composables. We can add additional information like accessibility labels, content description, or process some user input, make it clickable, scrollable, draggable, zoomable, and finally probably also focusable. So yeah, looks actually pretty much the same as the cuttlefish does underwater to do its camouflage thing. Normally, it's like modifiers probably not that complicated. You think you just read it from top to bottom, but it can happen actually that it's unintuitive in some cases, at least if you think about it too long. For example, like here, imagine we've got a text composable and just 3 modifiers, and if we swap their order, we get totally different results. So one good thing is definitely to know order matters. Just show you the little source code snippet to it. So imagine which order leads to which result. So if we use the padding first, seems like there's no padding at all visible, but it's going to the outside probably. And afterwards, just we get the background and the border followed, and text and everything looks very tightly stacked. If we position the padding modifier in the center, it would at least then pad intrinsically our border and the text, of course. If we place the padding modifier at the end, like in the source code snippet you see, we get the result we most likely want to achieve, and that means like it's just padding our text, so just all following stuff after the padding modifier is applied. So yeah, that's like general modifier logic. But here another, probably for me it was a confusing example. If you apply 2 border modifiers to a box composable and swap the position in between of the size and padding modifiers, you get the different results you see. Like the upper one seems to be a little bit smaller than the middle centered one, and the blue one at the bottom is just the reference box there, so you can compare it. That blue box has a 200 dp size, so it seems like compared to the upper one, it matches also with the blue box border, I mean, but with the centered one, it's matching more with the magenta version. Why is it actually like that? Because, yeah, the modifier pads just the stuff afterwards. So in the first case, the border comes in, doesn't know which size it has, but luckily next modifier is a size modifier, so it knows like, okay, I need the size to be 200 dp. Then the padding comes in with a 16 dp and says, okay, everything afterwards will be padded intrinsically with 16 dp. So that's the cause why it's like looking definitely smaller. In the other way around, we say, okay, whatever we've got after our border and padding will be then added actually with the 16 dp, and the magenta version gets painted at 200 and 200 dp. So that's a little bit unintuitive and unexpected if you just write your modifiers without watching out for the order. Another probably unexpected example is if you use, also again, a box composable and just apply scale and offset modifiers and swap their position. Because yeah, in some graphics libraries, it's more like if you scale something, it's going to be scaled from the originated center. But in that case, also, if you want to scale the offset width, you have to put it after the scale modifier. So the red example has the scale modifier first and the offset afterwards, so that is also scaled by 2. And the purple one just has an offset by 50 dp, and then afterwards our box appears with 100 dp. So these are things that can be a little bit unintuitive in general regarding modifiers. Also, if you see some combination fun with applying multiple size modifiers, which can happen actually quite easily if you pass your modifier from composable to composable and use it on the first layer like you are supposed to do, and you just lose track what kind of modifiers are already in your chain. So you add your, desperately probably your magic number size modifier additionally to it, and unsure what happens then, probably. So for example, if we are very desperate and want to require size because we really want to force it afterwards and don't care what is in our stack before, we could then write stuff like fillmax size and afterwards our required size. But even if you see that your image is getting smaller, your layout node will still adhere to the first size modifier. So actually, in most cases, it gets centered in that layout node size from that which it has been given before. So even if we would have used a wrap content size or something, we would have reached the width. But yeah, if it's like aspect ratio not evenly, you have some overlapping stuff at the top and bottom. So in general, yeah, it's good to know that chaining multiple size modifiers does not work. It changes still how your composable looks like, but the layout node itself will always adhere to the first layout bounds and first size modifier it had. So that's something general good to know. Also, the compose phases in which modifiers are applied to plays a big role. So we have like these phases where the data coming in, and then composition is like what we want to show. The layout phase is more like where we want to place it, and drawing phases is how we want to render it. So size and padding modifiers are residing in the layout phase, therefore, and stuff like clip and rotate are residing in the drawing phase. And yeah, that has some implications on where we have influence on the size of the composable. Also, like in the layout phase, there's a specific part where the constraints are going to be defined, which we probably need later in our custom modifiers. So in the layout phase, it's always from parent to child, we traverse our UI tree, and each parent measures its children. Once the node has measured its own size, it's just reporting it back up to the UI tree. So that's happening before the drawing phase, and yeah, we have to keep that in mind. So what is now going on with the multi-platform modifiers? Is there any different? I'm coming from the Android side, so I always a little bit focused on the Android perspective, but I was wondering how is it possible that I can write source code multi-platform with modifiers and it's still working? So behind Compose Multiplatform, Compose Multiplatform does render completely from scratch using Skia, which is like a 2D graphics library from Google, and yeah, that's the ground base of all of it. We have no platform native widgets like with React stuff, but we got nice Material and Material 3 widgets out of the box, which yeah, is pretty nice from like always having my Android perspective on that. But now, still, how does it work for other platforms? Because Skia was not really available for iOS, web, or desktop. Skia is famous for its use by Flutter, for example, Android, Chrome OS, and many more, but there was still something to do. So luckily, JetBrains wrote that Skiko, which is Skia for Kotlin, and in case of like Android, we can go directly from Skia to Android. Otherwise, we have to use our Skiko thing, which is a wrapper for Skia, and then can do the same stuff like with Android than with the other platforms, and reach our Compose API on top of that, which has a part of also this canvas API where you can just draw directly into a canvas. So that's for the rendering, how they achieve it to do the same modifiers like with Jetpack Compose on the Android side. But now the question is like, can we really modify all platform UIs all at once, or is like anything unexpected, everything looking the same? Not sure. If you just write a little animation thing, yeah, good visible, where we swap and rotate stuff from actually on your one side you see Android in the center, desktop, and on the other side with the top bar and bottom bar, that's iOS version. I skipped web for now because it's not in early stages, but these three platforms are very good for production, I think, and I couldn't find any differences on that. I'm coming from a mobile-first world and thought, okay, is there like anything I can additionally do with modifiers, which I didn't do before because I'm not programming for desktop usually. And yeah, since we all like shortcuts as software engineers, there's a nice modifier, for example, on preview key event to add some shortcut capability to your composable. In that case, it's just listening to if someone presses CTRL and the key minus or equals on the key event key up, it would then just, let me show that, discard or save it. So whatever we do. So see, saved chars is now 10, discarded chars is now 5, and we did do that just by using a modifier. Next sample, so the cuttlefish is always accompanying us, are like the advanced modifiers. Let's see if they're, how advanced they are. Because just by, you can do much more than just setting background colors, make it clickable, focusable, and so on. You can, additionally to the canvas composable, also use drawing modifiers, which are like mainly 3 types of drawing modifiers. You have draw with content, where you have a base drawing modifier, and the good thing about it is you can control the drawing order and add other commands. Draw behind is more just a wrapper for draw with content set to drawing behind. And draw with cached, you should do that if you are doing large computations or having objects which definitely should be cached until any size changes or state variables change. So we have these 3 types, and as soon as you are inside a modifier like that, you are in a draw scope, which means it's a declarative, stateless drawing API, offers things like draw, shapes, and paths, and luckily there is no need to maintain our own state in that case. So we can just access also size and center of the drawing area, which can be important to then continue in your draw behind stuff and to recenter and calculate some constraints again. When should we use the canvas composable? Well, it's an easy thing for simple drawings, but actually just a convenience wrapper again for draw behind. If you click on it, the implementation side would show you it's spacer with a modifier draw behind on that. All these graphics modifiers are calculating their stuff in pixels and not in dp, but it's good for us if we to just support plenty of form factors, that we do our calculations using dp and then convert it just before the drawing phase to pixels, but not earlier. So let's see some fun samples what we can do with modifiers. There's a hide and seek game like with the cuttlefish again, where you have like a flashlighting effect accomplished by applying a modifier, and the pointer input moving around, and assume the cuttlefish appears on random positions. You could just use your flashlight to find your cuttlefish. Implementation of that is more going to, like, again, using draw with content. Well, let's start at the top first. Our column is having the pointer input, where we detect the drag gestures and get our offset, which we then later use in our draw with content part to set our flashlight effect to the right position and following our pointer. So we do in draw with content, we draw the content first, which is our icon below. And on top of that, we draw then a rectangle with a brush radial gradient, which is in the center transparent, and therefore just doing that flashlighting effect. Outside, it's like having a sort of purple color. So here you see we can nicely set the order of modifiers, and therefore achieve like a pretty fun result with like a flashlight effect. Warning before the next demo: if you have any photosensitivity, seizures, or epilepsy stuff, please look away for a second, because I'm a big fan of old computer games and they had a lot of glitch effects in there, so I thought probably we can achieve adding to any composable some glitch effects, and well, can look shocking, so I just show it for a second. Now it's gone. We actually, in that case, we've got a glitch modifier as a composed implementation, where we just also again draw behind the stuff. So meaning in that case, the glitch would not really be visible on an image. In that case, we would have to use another modifier. But yeah, just for the text composable, that was enough. Yeah, we are just drawing the rectangle there and shouldn't actually use caching because too many things are based on random stuff there. Yeah, another fun demonstration is if the cuttlefish would like to do its camouflage thing in our Compose world, how could he achieve that? Would it look actually totally the same for each platform? Again, we have iOS, desktop, and Android. And the cuttlefish is always trying to adapt the color of the background to hide. There's like a little delay integrated that you see while it's swapping the background image that the cuttlefish is there. So, but he's doing a good job hiding himself. The implementation for that is here that we've got a, how to say that, I don't know if you know the palette library, which is there for extracting dominant and vibrant colors from images. I'm using that to calculate my brush gradient. Actually, not the entire source code for that visible because that is not playing a role for our modifier. It's just like, imagine I've got a library called, I think, palette, kpalette. It's also available for multi-platform in the meantime. Where you then just extract the main colors of an image. And we get the two most prominent for doing that, and we are applying that to our icon with a modifier. Also first, before we apply draw with cache, you see probably there's also a graphics layer modifier, which is setting alpha to, just reducing it by 0.01, so that's not having a big impact, but I wanted to show that there are also modifiers like that. And because we are doing some brush gradient calculations before, and maybe want to remember that, and no sizes would change. Besides that, we are doing a draw with cache in that case. And then again, in the draw with content, we draw our content first, and on the z-axis, then we draw a rectangle on top of that, and by doing that with a brush gradient, we override the tint color of the cuttlefish, at least visually, it's doing that imagination. Regarding the graphics layer modifier from before with the alpha thing, there's some interesting stuff regarding size and placement. So if you imagine you would not just using alpha values, you would probably use some translation or rotation, stuff that's more resided in the drawing phase. Like I say, it only affects the drawing phase. Can happen that it becomes invisible if it leads to that the element gets out of the layout bounds of the composable at all. An example for that is like we've got a lost fish in that case. So imagine, we have just two images. Probably just check the first box with the white image first. Because the source code is only for one image. So we have two times fish image, one time with a red background, one time with a blue background. But we are doing a rotation by 9 degrees and also a graphics layer translation, like moving it far enough out of bounds. In the first sample, our parent actually is only also like having a width of 100 dp, just like our icon image, and therefore the second fish is not visible. I mean the fish that would have to be appeared in the red area. If we would have a wide enough width from our parent, it would like the lower version where you see the fish which is gone like a little rotated. But it's still the one that is related to our red box. So I mean, intention of that is actually to tell you to watch out when you rotate stuff and things that it doesn't get cut or become totally invisible. Then there's also the layout modifier. We can use things like make a growing box on each time we click it to a certain maximum value and to a certain min value. Here you see the source code for it. For only relevant part is the layout snippet. And there, interestingly, we get a measurable object inside there, and we get the constraints. And each time it's clicked, we want to increase the size, so we cross in with a rather if we reach the max width or go back to the min width. And that calculation tells us what our target width is then. And then by doing that, we can calculate our new constraints, round it to pixels, because we have to give it some pixels at the end, and measure our measurable again with these new calculated constraints, and then finally in the layout place our placeable relative on this layout coordinating system. Also, even if that was like in a different phase than the drawing phase, if the parent node is not big enough, it leads also to some weird results, like on the version where you see the 200 below. Because our box wants to grow to a width of 300, but the parent only allows the width of 200, and then it's doing some weird stuff where it starts and where it's placing. On the version with the 300 dp down there, you probably see the blue box at the maximum is growing a little bit too large. That's due to the rounding logic I applied. Yeah. So there are implications. Always watch out that your parent is large enough if you want to show that, and of course we always avoid magic numbers. Now, what about custom compose modifiers? If we want to make it reusable and economically friendly, what could we do? In theory, chaining existing modifiers together if we can, because then we are on the safe side regarding performance implications and stuff like that. Because you have to also know a composable function modifier can never be skipped because it has like a return value and cannot be skipped, has performance implications. And composable function modifiers, of course, must be called within a composable function. So if you invoke anything with animate, with float or something, you have to also annotate your modifier with a composable. So first, let's see how we can do a chained modifier. For example, if you want to streamline your app and always have a set of certain modifiers which should be applied everywhere, why not make it more handy and make a custom modifier that's just chaining other stuff. So we could do that by just returning this padding and background on the modifier, or we could do it a little more if we want to have influence on the order, doing pretty much the same, but we could also just use a normal padding modifier and then draw again with content a rectangle, first our content, and then on the z-axis again a rectangle on top, and give that some background color, probably with some alpha values, because otherwise you wouldn't see your content anymore. Another thing you could achieve is like writing, I don't know, some upside down effects, or just some fun modifiers regarding the draw modifiers. In that case, we are just overwriting the draw method where we scale things on the y-axis by -1, and that leads to that upside down effect. At the lower bottom of the source code, you see how we conveniently just assign it to this then upside down modifier. And of course, there's also like modifier factory. It's annotated in that case with composable because I'm using animate float as state. And most important thing of that slide is that I wanted to tell We always have to continue the modifier chain, never break it, because otherwise all modifiers before in the chain get lost, and that's not the intention of the concept. So use this then modifier, or implicitly return graphics layer in this case. So we could have also left away this then modifier, just written graphics layer directly, because anyway it's already this alpha gleich alpha. Yeah, a bit confusing thing for me was like modifiers in combination, or custom modifiers in combination with a composition local. So imagine if you have that composition local provider providing first the green color, then we assign our background modifier with that alpha background size 50, and we get again a composition local provider, this time providing the red color, and then finally the box getting the modifier applied. I don't know what you expect the color to be. I didn't expect it, so it's green. If you, the problem there is it's taking the content local provider from the callee side and not from the caller side. If you expected it other way around, like I did, you should use the Node API for that. Let's see how we can do it with a Node API instead. Here's just a comparison screen where I have a switch down there that says like I can use Node API or don't. The upper part is quite the same as before. We have 2 times composition local providers, 1 time with a green color and later with a red color. And what we want to achieve is actually that it takes the red color, because that modifier is getting applied afterwards, and that's more the intuitive expectation in that case. So the implementation for that Node API part would look like that. We have that local background modifier, just returning the background color, and also, again, this then background. The background node definition, we have some boilerplate code there, but or at least compared to the other version, it's much more source code, where we have to override the content draw scope draw function and set the color there. Also, we have the modifier node element as a data object. Oh, thanks. Okay, thanks. Okay, now we've got the modifier node element as a data object. Since we're not updating any colors, that's not implemented now, but plays a role later. So now if we check how that looks like when we click it, surprise, that works more like as I would understand it. So we get the red color in case we implement same logic with the Node API, but with the other version we would get the green version. Here again a sample for a quite similar modifier node element where we just try to hide some super secret text by blacking it out. There you, the most important part about it is that you always have to or should implement equals in hash code for your modifier node element, because otherwise it would be updated all the time and leading to poor performance. A good way to achieve that is just using a data class, then you're on the safe side. So I was wondering then, if we have so many options to write different modifiers, we have the composable modifier, the composed factory, the Node API, and it's confusing what you should use when, and if probably Node API is too much source code or not, or if you're always needed. So it's like a little sort of flow chart to make the decision easier. So ask yourself, do I have a simple behavior or a simple decoration? If yes, then go with the composable modifier. If no, then ask yourself, do I need fine-grained control while performance is critical? If yes, go with a Node API. Anyway, they said everything is replaced on the JetBrains Compose side with that and leading to an 80% performance boost. So feels like always a good idea to go on the performance good side. If you would answer that question still with no, I would assume still ask yourself, do I need a custom modifier with a state, effects, or some multiple steps? If yes, go with the Node API. It's anyway best practice. Compose Factory is a little bit tossed to that. But if you answered all the questions with no, then again, go with the Compose modifier. It cannot be that complicated in that case. Yeah, finally, we're coming to some modifier madness, where a little bit inspired by MadSkill series, but probably also some moments where I thought, oh, that's a modifier behaving a little bit unexpected. So first out of 3 is, yeah, there can be visual differences, but in most cases you can solve it. But I found a version where the same modifier leads to different appearance or behavior. An example for that is actually the focus animation behavior. Yeah, demonstration for that is, imagine we just have a screen, whatever, lazy row doesn't play a role. Let's say we have a box which is clickable. That's like the only relevant part. We have a box being clickable. And since iOS and Android just looked quite the same, I placed only one mobile video, and the other video shows the desktop version. And if you see on the mobile side, if I click a half-cut item, nothing happens. But if I click it on a desktop, it gets scrolled into the view. So, and I just applied a clickable modifier, and I didn't expect any different behavior on platforms. If you want to prevent that, you can. You can actually set focus properties, can focus to false. Doesn't have any impact then for the mobile versions, but on desktop it wouldn't start scrolling automatically, and then you can streamline the behavior and set everything evenly to scroll to the position you want to. Important also is to apply the focus properties modifier just before the clickable modifier, or at least some position before, not afterwards, then it wouldn't have any impact anymore. So order always matters. Yeah, madness part 2 of 3 was for me. I wanted to write a custom modifier, but then something happened. For example, I thought it's a good idea to have a modifier like .remove background, and then calling some AI background removals tools like PhotoRoom API, and just being able to remove backgrounds of composables. And there's with Compose 1.7 a thing called graphics layer to image bitmap, but actually it was not yet available for Compose Multiplatform. So I'm waiting a little bit for getting this run. And then I thought, okay, just implement something else, just do a lazy background image modifier, which would download your background image and apply it to your composable. But also I had a weird experience there because I wanted to do a byte read channel to bitmap, and the import actually existed and was resolved, but it was not there at runtime. So, because I still wanted to achieve it, I wrote like a little image download sample with platform-specific stuff needed. Here you can see the sample. We have just some fade-in, fade-out animation for my click me button. And then, also animation where the images come in. Until they are loaded, you see the Compose Multiplatform logo as a placeholder, and then just some random images are being loaded due to applying my custom modifier. How do I achieve that? In my awesome screen, I have a show content boolean, and it decides if I show that down there. And button modifier is just cycle fading or not, regarding if it's showing content or not. And in the box section, you see my custom modifier lazy background image, which uses just some random pixel URL to retrieve some photo image by 500 resolution, also adding the painter resource, Compose Multiplatform Drawable as my placeholder image. And then now the platform-specific part comes. Here is also the cycle fade implementation and wrapped it for the launched effect and applying again this then modifier graphics layer because we do not want to break our modifier chain. And in the lazy background image, we just also using a launch effect to get our response from the service. In case of an HTTP OK result, we can then read the response as body channel and convert it to bitmap at the end. And that's the part where we needed platform-specific stuff, slightly different for Android and desktop and iOS. But I'm sure the imports are going to be resolved soon. One more thing I wanted to add to my madness section is performance. It can have implication, but Skiko and Skia normally ensure consistent performance on all platforms. So if you're doing nothing too fancy, just using modifiers the normal way and not doing draw content all the time yourself, you should be on the safe side. Composable function modifiers cannot be skipped. Keep that in mind because they have a return value. And also for that modifier node element, it must implement equals in hash code. So these are things, if you don't keep that in mind, rather go with the normal modifier chaining. So for me, the impact on multi-platform development is like modify all of them at once. Yeah, it's working quite smoothly. Actually, coming from the Android Jetpack Compose world, it's a smooth transition to go over there. But UI behavior can be slightly different. You have to watch out for tiny changes if you they are easy to overlook if you're built not all the time for all platforms. So probably, I don't know, some screenshot testing for that could be a good idea. And embracing different user inputs, like if you're coming from a mobile-first world and forget that desktop users want to use shortcuts, probably also a good idea to think about it, what each platform wants to have and what are the expectations of the users. And of course, it's most enjoyable with less platform-specific code and also having like the same APIs, like adapting quite quickly to what is coming from the Android Jetpack Compose world. So yes, that's it from me. Thank you so much. And don't forget to vote.